Hi, hello everyone. This is Shakil from Hindustan University, Chennai, India. Before jumping into our project, I would like to show my gratitude to the global level hackathon event organizer, IBM-Z, as well as the staff members, and also the Shooting Star Foundation communities. Thank you. Thank you for such opportunity. So let's begin.
At a current urban world, air and sound pollution have a big negative impact on our emotion and well-being. Imagine the air we breathe filled with the harmful stuff, making us sick every day, hurting our environment. Think about a person with asthma. Breathing is usually easy for everyone, but for them it can be very hard. They may feel frustrated about their travel planning, about their next plan outside, which will be very stressful for them to design. So now let's talk about the heart patient. The noisy world we live in can make them stressed. The constant loud sounds around us can make them feel anxious and can even disturb their sleep. It's not just about their hearts, it's about how it makes them feel, which leads to the various heart diseases. So here comes our solution, Enviro-Predict HealthGuard Plus, which is a IoT and data science based solution for asthma and heart disease patients. Basically, our idea is to establish the sensor all over the cities to collect the various types of air and sound quality data. With those data collected, we do the pre-processing as we all do for the analysis, and we'll deploy the machine learning algorithm and we'll let the model to run on the future prediction, and with that prediction we'll give the patient a SMS alert about their future travel plans. So this is the basic and the rough idea behind the project. So this is the basic IoT device which will be deployed across the city to collect the various kinds of air and sound quality data, which will be used for the future prediction for the specific patient travel plans. So we'll be storing the data of the sensors in the specific website called ThinkSpeak, which is a ready-made website for the IoT data collections, as well as it will show the real-time monitoring. So here you can see we are exporting our data in the CSV format. So this is air and sound quality data. So you can see these data will be. So next, Olivia from our team will explain you the further process of data analysis and prediction model.
Hi, this is Olivia Nakacho from Uganda, student at Makerere University in my final year. So yeah, from what Shakil has been trying to explain about our project, this is the kind of data we managed to extract from our IoT system. We had the city data. This is the city data, and then this is the healthy data that we managed to collect around from people. So we had two data sets roughly, the user data and then the city data. The user data contained the information about the users, whereas the city data contained the different cities in terms of latitudes and longitudes, and then the PM2.5 values, temperature, and so on. Both data sets were cleaned, whereby we dropped the missing values, we visualized it, and we used it for merging the two data sets to form one data set. So before the merging, this is the kind of data we had visually. This is the user data, and then this is the city data in terms of the air quality. Then this is in terms of the diseases. So after merging the data using the latitudes and longitudes, we split the data into two portions, the training and testing, whereby 70 was for training and 30 was for testing. We scaled it up so that we have a uniform kind of data. So we used different algorithms such as support vector, decision tree, logistic regression, and KNN. Then for those that had poor accuracy, we used different techniques to improve the accuracy, whereby we hyper parameter tuned them using grid search and random search. So among the algorithms that were used, the decision tree algorithm has outperformed the other algorithms where it had an accuracy of 1. For us, the logistic regression had an accuracy of 0.7. So we hyperparameter tuned the logistic regression model and it gave us an accuracy of 0.9.
Thank you, Olivia. That's a great insight. Let's take a look into the alerting mechanism. The left side is SMS1, the right side one is the call alert mechanism.
Hello. An event called temperature_exceed occurred on the Maker webhook service.